Hello students, here's a good news for you all. You can now watch my videos in Hindi also. All you have got to do is go to the specific video, click on settings, next click on audio tracks and then change the language settings from English to Hindi. You now have the dubbed version of this video in Hindi. Hello students, welcome back. Let's take up another question. This question is from Light chapter and the question is the values of absolute refractive indices of kerosene and water are 1.44 and 1.33 respectively. Compare the two media on the basis of their optical density, mass density, relative speed of propagation of light. What do you infer on the basis of above comparison? So first let us understand what is optical density and what is mass density. So optical density is a property of transparent materials that describe how much they impede the speed of light passing through them. So now let's see how optical density affects the speed of light. Now optical density quantifies how much a material slows down the speed of light as it travels through it. So a medium with a greater optical density will slow down the speed more than a medium whose optical density is less. Second is bending of light. It also describes the extent to which an optically dense medium bends the transmitted light either towards or away from the normal. So if a ray of light is traveling from a rarer medium to a denser medium, then in the denser medium, the light ray will travel towards the normal. That is, it will bend towards the normal, whereas if a light ray is traveling from a denser medium to a rarer medium, then while traveling through the rarer medium, the light ray will bend away from the normal. So by knowing the optical densities of the two medium, we can know whether a light ray will travel towards the normal or away from the normal when it passes through that medium. The third is absorption. So the higher optical density indicates that the material absorbs more light, allowing less light to pass through it. So a medium with a higher optical density will absorb more light in comparison to a medium with lower optical density. Then the next one is relationship to refractive index. The optical density is directly related to the refractive index of a material. Materials with higher refractive index have a higher optical density. That means the medium with a higher refractive index will have a higher optical density. A material with higher refractive index has a higher optical density. The slower the speed of light will travel in that medium. So by looking at the refractive index of the medium, we can understand the optical density of that medium in comparison to other medium. Now coming to the mass density. Mass density is defined as the mass per unit volume. This parameter can be expressed using different units such as kilogram per meter cube. So mathematically, mass density is expressed using the formula rho is equal to mass by volume or mass per unit volume, whereas rho is the mass density, m is the mass of the fluid or solid, and v is the volume of the fluid or solid. So now if we compare kerosene and water on the basis of optical density, we can write the absolute refractive index of kerosene is 1.44 and the absolute refractive index of water is 1.33. Now absolute refractive index means the refractive index of kerosene with respect to air, and absolute refractive index of water means the refractive index of water with respect to air. So kerosene has an absolute refractive index of 1.44 and water 1.33. Since the refractive index of kerosene is greater than that of water, kerosene is considered optically denser than water. So whenever a ray of light is passing through kerosene, it enters water. That means it's traveling from a denser medium to a rarer medium. And we know that when a ray of light enters a rarer medium from a denser medium, it bends away from the normal. Hence this ray of light bends away from the normal because water is a rarer medium. Now let us compare on the basis of their mass density. Now kerosene has a lower mass density than water. It is evident because kerosene floats in water. So here you can see this is kerosene which is floating on water, and here we have water. So we say that the mass density of kerosene is less than that of water. Now let us compare in terms of their relative speed of propagation of light. The speed of light in a medium is inversely proportional to its refractive index, as is given by the formula V is equal to C by N. How did we get this formula? We know refractive index N is equal to C by V. So V will be C by n. So v is the speed of light in the given medium, c is the speed of light in vacuum, and n is the refractive index of the medium. Since kerosene has a higher refractive index of 1.44 than water, which is 1.33, the speed of light in kerosene will be slower than that of water. That is, light will travel with a slower speed in kerosene than in water. So the last part of the question is, what do we conclude from this? We conclude that kerosene is optically denser than water, meaning light travels slower in kerosene. However, kerosene has a lower mass density than water, which is why it floats on water. This demonstrates that optical density and mass density are distinct properties and are not directly correlated. So with that, we come to the end of this video. I hope you found this video helpful. Please like this video, share it, and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.